rows within the country partition. So you can see that that's what we did in this query over here. When we run it, the key to understanding that is this right here, right? The row unbound proceeding in the order by ascending rows unbound. You can see that right here as we are running that query, and that limits us basically for example, let's take a look at Germany, right? Germany and Sweden, etc. So you can see here it limits it for the row, using the row unbound function here. And you can see that the list of the books by country, it's sorted by the number of downloads in ascending order. Here we see it for Germany, right? Germany is the Harry Potter, right? And then we also have, you can see here, so Ultimate Quiz. Quiz book is the fewest downloads here, so you can actually see that. And then also you can see for Sweden, it's Burn for Me, which with the fewest in Sweden. So this is how it works. It's actually a very powerful way to leverage it for different types of SQL analytics. Let's also look at something really powerful and something really simple at the same time. If, for example, one of the questions from our data engineer is, hey, I'm going against a large fact table, etc., that's in my warehouse, and I'm trying to get the results from that query, and the query takes, let's say, 30 seconds or 40 seconds, etc., because it's just a huge data set, right? There's multiple ways to optimize, but if you wanted to give your data engineer a very quick and efficient way to get started with this, right? There is, instead of using just a regular count, we can actually use what is called approximate count distinct, which will give us approximate count distinct returns the result basically with 2% accuracy, but it actually is able to give us much better performance versus a regular count function. Here you can see if we do that against a sales table, right, and it returns, for example, since we're doing distinct, right, we know that there are distinct 1 million customer IDs, but the query took about 49-50 seconds. So if we run approximate count on the same data, what we see is we're able to just really see how much quite less time. The more data that you have, the better it is. And now you can see approximate row distinct came back in 11 seconds instead of taking 50 seconds. That's actually one of the more powerful things that you can use. Is another way to basically leverage approximate row counts. What it does is it's able to leverage what is called a hyperlog log accuracy to reduce the query latency in exchange for a small reduction in accuracy. So yes, we do get a 2% less accuracy, right? And you can see that difference here. Instead of 1 million, it's a little bit higher. So there is a 2% less accuracy, but we are also reducing the latency. We just turn something that was running in 49 seconds down to 11 seconds. And that's actually really one of the more powerful things. So there are a lot of functions like this in Synapse Analytics. We've just touched the very beginning. And what you can do is in the documentation, in the Knowledge Center, there are a lot of great functions that's available for windowing, analytics, aggregate, and many other types of functions that really help us use SQL for very optimal analytics across the board. All right, so let's take a look at how to actually load data and use some of the recommended practices with Azure Synapse dedicated SQL pools. Now, remember that with Synapse, we get multiple ways to load data into Synapse, but one of the things is we want to be able to efficiently load it. Some of the recommended practices that we should follow